Artem. I'm from Moscow Institute of Physics and Technology, and today I am happy to introduce you the second task of IGLU competition, namely the builder task. So many of you may already be familiar with our general motivation. So we, in general, are interested in answering the following research questions: how to build interactive agents that learn to solve a task while provided with grounded natural language instructions. What does this mean? This means that we have an asymmetric game with two players. One of them is a teacher and another one is a student. They can interact through a chat, through the conversation, and the teacher should teach a student to do something. We will see that the something is build instruction in Minecraft-like game. So this main research question can be subdivided into two sub-questions, each yielding its own task of the competition. First one is how to teach, and this question yields the architect task, which you might have heard yesterday in the previous workshop. So briefly, in this task, we are interested in learning NLP models that are capable of instructing the artificial builders. And in the second task, our question of interest is how to learn. Precisely, we would like to know what methods should be used to train a student agent that can follow given instructions. So you need to train or create some sort of student that has access to the conversation between human players, as we will see next. And the student should learn to do something. And let me give you an example of what they are actually doing. So as the role of teacher, we have the architect player, and as the role of builder, as the role of the student, we have the builder player. They are interacting through the chat interface, and the architect has access to the target structure. The goal of both of them is to reproduce that kind of target structure in the grid world. As I said, they can only interact through the chat. Architect has access to, except the target structure, it has access to the building region and to the things which are built by the builder so far. So the goal is to build the target structure. And now I would like to dive into the details about the second task, namely the builder task. So as I said, your goal, the goal of your agent, which you create, is to build target structure given the past conversation between human architect and builder. So in this example, which you might have seen in previous paper or in our previous talks. So in this paper, there is a data set collected by fellow researchers. And this data set consists of many game sessions between human architect and builder. And from them, we can extract the target structures and human conversations. So your agent is provided with such conversation, and it should extract the information about the target structure and reproduce it. So your builder is able to navigate across the world. It is able to place and break blocks. And also we have, as I said, the data set, and we are collecting more data right now. This data set will consist of many more architect-builder interactions, I mean conversations and target structures. So this dataset is assumed to be used as a demonstration for your reinforcement learning agent or whatever you create. So as we pose our task as a reinforcement learning problem, we have provided the environment for training your models. So let's talk about how this environment is structured. First of all, your environment has the observations. The observation space consists of 64 by 64 3-channel POV images. So you are provided with first-person view of your builder. It consists of inverter state. At the beginning of the game, the builder has six different colors of blocks, each of them precisely 20 items of each of them. And the builder has access to the chat between human architect and builder. And also the environment holds the target structure in its internals. You cannot access the target structure, but you can access it through the rewards. You can obtain information about target through rewards, which I will talk about later. So also it's worth to note that your agent, not your agent, you are given 2 more components, but these 2 components are provided only on the train time. So when you are creating your agent, you can access them, but on the evaluation time, these are not exposed to the agent. So the first one is the agent position. It is simply a 5-dimensional vector for x, y, z coordinates and 2 camera angles. And the second one is the grid world state. It is simply a NumPy array, a 3D NumPy array with IDs of blocks currently placed. Also, your agent is able to navigate across the environment. There are a bunch of commands for movement, a bunch of commands for controlling the camera. As I said, your agent is able to break and place blocks, and of course to select blocks of different types. As I said, there are 6 unique colors of blocks. So reinforcement learning wouldn't be RL without rewards, and we have the rewards as well. I will not talk about the rewards in much depth, so just keep in mind that your agent is given with +2 if the current grid gets closer to the target. Otherwise, not otherwise, it is given with -2 if the current grid gets more far from the target. For example, consider the case when we have the target structure like this and the agent has built this one. For example, if we would break this block, the agent would be provided with -2. In all other cases, for example, if the agent had placed a block somewhere here, it would be given with -1 or +1 depending on the situation. For example, if it plays block, it would be a -1. So speaking about the baseline, our main idea for the baseline is to split the task, the builder task, into 2 subtasks. The first one assumes a supervisory learned solution. Namely, you should create a model that takes the conversation and predicts the target structure, as simple as that. And the second part is learned by reinforcement learning. And in this part, you should take that target structure and map it along with RGB observation with inventory counts to the corresponding action. So that's it. That's how baseline work. Currently, we have some sort of baseline published into the repository, and many other baselines are on their way to you. So just be patient and wait for a while. We will publish them as soon as possible. So speaking about the data set, we are currently collecting more data, and here is the example video rendered by our environment. So originally, there is a Craft Assist game, which mimics Minecraft but can be run in the browser. Using this game, we are collecting data through crowdsourcing tools, and then we are able to map the sequence of actions provided by the Craft Assist into the representation conceivable by Melmo or IGLU. I mean IGLU environment. So just be aware that you will be provided with dataset with a lot of videos, chats, and sequences of actions. So now we will dive into a bit more details about how we will evaluate your solution precisely. For automatic evaluation, we will have three metrics: completion rate, success rate, and rewards. Each metric is defined here, is defined in terms of like for a specific episode and a specific task. But once this is calculated, we can average it across many episodes and across many tasks. So for example, for completion rate, we have for some task a target grid, and in the end of the episode, the current grid. The resultant grid, which contains blocks placed by the agent. And we can calculate the maximal intersection size between them, whatever it is. I will describe it a bit later, and divide it by the size of target grid. The maximal intersection size is always less than target grid, so this means that this metric is less than 1. Once it is calculated for one task and for one episode, we can run a number of episodes to account for randomness in the agents and in the environment, and average it over number of tasks to evaluate how good the agent is at the generalization between tasks. Another metric is the success rate. It's also quite simple. The success rate is defined as 1 if the structure is complete by the end of the episode, and 0 otherwise. So we can claim that the success rate is like a sparse version of the completion rate, and it is also average over the episodes and over the tasks. The third metric is the reward, and this is simply an accumulated reward of the episodes averaged over multiple episodes and multiple tasks. This is how we calculate the maximal intersection. This is a pseudocode equivalent to the actual one, so it may seem to you a bit naive and slow, but we are using much more optimized version. It's just for your information. So we consider all rotation around the vertical axis of the target grid, and we shift the target grid over all possible shifts compared to the current one. So this function is provided with current grid and target grid. So once we are having some pair of shift coordinates, we shift our target grid. We compare it with the current one, just calculate where they are equal and the target grid is not 0. because 0 is correspond to the absence of the block. And then we just maximize, we calculate the maximal achieved value of the intersection. So once we considered all of the shifts, we rotate the target grid around vertical axis by 90 degrees. That's it. And we use just this this value in this completion rate metric. After we have phase 1 of the computation completed, we will launch phase 2, in which we will run the human evaluation of your agents. Precisely, we will take 3 best performing agents and pair them with the human architects to assess the quality of build structures. In particular, we will assessing 2 different aspects of quality of the structures. First one is the correctness of the structure, and the second one is the naturalness of the structure. That's it. So let's move to the more practical part. I mean, how to prepare a submission. First of all, you should prepare a metadata file. It is a YAML structured file, which should possess only one field, the action space. In this case, it's human level type. Other types you can find by this link. I believe it's provided somewhere else, not only in this presentation. So there is 2 more options for action spaces. There is a discrete action space and the continuous action space. The difference between them is that for discrete action space, the agent can step over the integer positions in the grid, and for continuous action space, the agent can fly freely even through the blocks and even through the air to just build the structure. The human level action space is the most basic one, and it is essentially the same with the one used in mineral competition. So the next step you should take is to create your agent. You should define 2 functions. The first one is the init method. You are provided with only one argument, the action space, and it is the object defined by this value. So if it is human level, your action space would be structured as human level action space. So you can, for example, load data you have submitted with your code. You can initialize your model, but be aware that you have no internet access while loading your model and loading your agent. The next step is to define act method, and you can think of that as an inverted reinforcement learning problem. So usually we have an agent and a black box environment, but in our case we have the environment and your black box agent. We consider your agent as black box. So we have environment, we run the environment, and we are providing the agent the standard reinforcement learning tuples from the environment. So your agent should just return the proper action from the action space. So the dummy agent is returning just a random sample from the action space. And also be aware that you're not able to print anything into stdout or stdr, because we would like to avoid cheating, because you can get access to the output of your code. I mean, not the output of your code, but the output of the ingestion program, the whole ingestion program. And if you would be allowed to print anything, you could like print the chat between architect and builder and take the chat. So this is why it is suppressed. As you might have seen, we published the starting kit, and it is structured as follows. First of all, it has a metadata file, which I have described before. It just contains the meta information of your agent, the request action space, etc. There is a custom agent.py file with your agent itself. Also, there is a submittable file, sample submission random.zip, which you can just take and submit to the system. Also, there is a test submission.py file, which you can use to check your agent for the bugs or for other problems. We highly suggest you to test your submission before actually submitting it, because there is a technical quota for number of submissions. And also there is a requirements.txt. If you want to have some additional libraries, you can add that file to the sample submission, and we will install any other libraries you want. So I think we can debug the submission. We can try to debug the submission. So can you see my VS Code?
Yes, we can.
Okay, nice. So here is the custom agent.py I have just shown you in the presentation, and this is the test submission.py I have talked about in the slides. We can run this file by just running the VS Code. So I'm just running the test submission.py without any arguments, and here it is. I'm in the debugger. First of all, be aware that you can enable or disable the fake reset. The fake reset is simply the operation that resets the environment without actually resetting the environment, whatever it is. So you can, if you're interested, you can listen for my talk for the data fest. It is in the Twitter of IGLU. So we can disable it by exposing this environment variable. So if I run the code, I see that we are creating the agent here, and we can step next to actually resetting the environment. Now the environment is actually creating the Minecraft instance, so we need to wait for a while, and I think I can answer some questions while we are waiting.
Are there any questions?
Nice.
It's done.
So what happens next? The next step is calling the agent.act, and this will lead us to this line. Let's see. Yes, we are here. And what goes next? We just taking action from the agent, providing it to the environment, calculating the reward, calculating the maximum intersection, and again. So I will speed this up a bit. So right now it's in this loop, and in the end of the episode, here we are informing the agent that we are done with done equal to true, and we can measure the reward, the success rate, and the completion rate. So as I said, the the success rate is just 1 or 0. If they're equal or not, the completion rate is the maximal intersection divided by the target grid size. And let's see what it goes. So right, we have reward equal to -29. We have success rate 0 and completion rate 0.6. Great. I think we are able to run a number of more trials. And so instead of actual tasks, here is just a dummy task where there is some like a fake conversation between architect and builder, and just some simple grid with 2 blocks stacked on top of each other. It's quite slow because we did not disable the fake reset, which takes around 30 seconds, if I remember correctly. But still, well, I think we can stop this. So regarding the overall schedule, now the competition is running. I believe it will run at least for a month if we will not extend the competition. So our next steps is to evaluate the agents on unseen instances, when we will have some sort of leaderboard, which you might have seen in the Coda lab. So in the stage 2, after the stage 1 will end, in the stage 2 we will select top 3 performing models overall. We will deploy them into some server and run the crowdsourcing evaluation. Finally, we will report final results and award the winners. So thank you very much. I think we can start answering the questions.
Thank you so much, Artem. Does anyone has any questions? For people who joined late, we will publish the recordings or recording of this session at the website, so please stay tuned. And if you don't have a lot of questions at the moment, we can cut it short. And if anyone has any questions, you can always reach out to the organizers, namely Artem, for the task 2 in our Slack channel. So the last call for the questions. If we don't have any, I suggest we just cut it short. Okay, we don't. So thank you so much, Artem. That was a great presentation.
Thank you.
Thank you. I'm going to stop the recording.